Welcome to an incredible journey through the world of mathematics. In this video, we're going to dive into the fascinating concepts that have shaped not just the academic world, but the entire universe. We'll start with the very basics: numbers and counting, algebra, geometry, calculus, and even mind-bending subjects like cryptography, chaos theory, and topology. By the end of this video, you'll see that math isn't just something you learn in school. It's the language of the universe itself. Ready to explore? Let's start with the origin of everything in math. Section 1. The origin of numbers, the building blocks of everything. Let's go back in time to when humans had no way to count. It seems impossible now, but at one point, our ancestors had no concept of numbers. Counting sheep. Nope, they were just sheep, not 5, 10, or 15 sheep. Then came the breakthrough. Numbers were invented to keep track of things, and from that simple beginning, everything exploded. Today, we use the decimal system based on 10 digits minus 0 through 9. Why 10? Look at your hands. We have 10 fingers, and that's where our number system comes from. But what if we used only 8 fingers instead? We might use a base 8 system where after the number 7, we jump straight to 10, which in that system would be what we call 8. In fact, mathematicians think that using a base 12 system would make calculations easier. Why? Because 12 is divisible by more numbers than 10. Example: if you're trying to divide something into smaller pieces, using 12 might allow for more even divisions. For instance, you can divide 12 into 1, 2, 3, 4, and 6 equally. Try doing that with 10. You'd struggle to divide it evenly among 3 people without some leftovers. Fun fact: computers don't use 10 digits at all. They use only 2, 0 and 1. And that's called binary. With just these 2 digits, computers perform all the complex tasks we rely on today, from sending emails to launching rockets into space. Example: think of binary as a series of light switches. Each switch can either be off, 0, or on, 1. Section 2. Logic, the core of all mathematical thinking. Now, we get into the backbone of all mathematical reasoning. Logic. Logic is what lets us make sense of numbers and operations, and it's been around for over 2,500 years. Imagine this scenario. If it's raining, then the ground is wet. Pretty obvious, right? But here's a twist. If the ground is no too wet, then it is no too raining. Is that true too? Example: consider the statement, if the light is on, then the switch is up. The reverse, if the switch is down, then the light is off, is also true. These logical relationships help us build proofs and solve complex problems. Example: take the classic logic puzzle. You have 2 doors, one leads to freedom and the other to doom. You can ask one guard one question. If one guard always tells the truth and the other always lies, what do you ask to find the door to freedom? You would ask either guard. If I ask the other guard which door leads to freedom, what would they say? Then choose the opposite door. This demonstrates the power of logic and reasoning in problem solving. This kind of reasoning is essential when proving more complicated theorems in math. Logic helps us make sure our math is sound, especially when things get complex. Section 3. Algebra, the language of the universe. Algebra, the land of X, Y, and Z. Algebra is about finding the unknown. Think of it as the detective work of mathematics. What's amazing is that algebra doesn't just solve everyday problems like calculating the speed of a car or the price of a pizza. It helps us understand the universe itself. Example: if you want to find out how far you can drive with a certain amount of gas, you might use the formula: distance equals speed x time. If you drive at 60 miles per hour for 2 hours, how far do you go? Plugging in the numbers gives you a distance of 120 miles. Example: another common use of algebra is in budgeting. If you have a monthly income of $3,000 and you want to save a certain amount, you can create an equation: savings equals income expenses. If your expenses are $2,000, then your savings would be $1,000. This helps you plan your finances effectively. Consider the equation for gravity, the movement of planets, or the expansion of galaxies. All of it can be expressed with algebra. It's no exaggeration to say that without algebra, modern science wouldn't exist. But algebra isn't just about finding x. There's a more advanced form called linear algebra, which uses matrices and vectors to solve much more complex problems, like how graphics in video games are rendered or how AI makes decisions. Example: in video game development, matrices are used to transform objects in 3D space, allowing characters to move and rotate in a realistic way. When you turn your character, linear algebra calculates the necessary transformations to make it look smooth. Fun fact: algebra can even help explain how Netflix recommends the next show you'll want to binge watch by analyzing patterns in data. Section 4. Geometry, the blueprint of the world. Let's move on to geometry, where shapes, sizes, and spaces rule. Geometry isn't just about drawing triangles and circles in class. It's everywhere. From the pyramids of Egypt to the screen you're watching right now, geometry shapes our world in ways we often take for granted. Example: think about designing a house. Architects use geometry to create blueprints that ensure the building is structurally sound and aesthetically pleasing. They calculate angles, areas, and volumes to maximize space and ensure stability. One of the founding fathers of geometry, Euclid, wrote Elements, a book that laid out the rules for understanding shapes, angles, and distances. His work became so influential that we still use many of his principles today, over 2,000 years later. Example: in sports, geometry plays a crucial role. For instance, in basketball, players must understand angles to make successful shots. A well-aimed shot from the right angle has a higher chance of going in the hoop. But geometry goes even deeper. It's used to map the stars, design cities, and even create the devices we use every day. Without geometry, there'd be no way to build bridges, plan out road systems, or figure out how to land a spacecraft on the moon. Example: in medicine, surgeons rely on geometry to plan their cuts during operations, ensuring they avoid critical structures and achieve the desired outcome. Section 5. Calculus, the mathematics of change. Now, let's talk about something that transformed math forever: calculus. If algebra is about finding unknowns, calculus is about understanding change. It was independently developed by two giants of mathematics, Isaac Newton and Gottfried Wilhelm Leibniz, and it gave us the tools to deal with motion, growth, and decay. Here's an example. Imagine driving a car. Algebra could tell you your average speed over the course of a trip, but calculus can tell you your exact speed at any given moment. That's a pretty big difference. Example: if you're driving a car and you press the accelerator, calculus helps you understand how your speed changes over time. You can calculate your instantaneous acceleration, how quickly your speed is increasing at that exact moment, using calculus. Calculus is the math behind everything from predicting the orbits of planets to determining how fast a disease spreads. In fact, Einstein's theory of relativity, which revolutionized physics, wouldn't have been possible without calculus. Example: in biology, calculus can be used to model population growth. If a population of rabbits grows exponentially, calculus helps predict how many rabbits will be there in the future based on current growth rates. Fun fact: calculus is used by companies like Google and Facebook to analyze data in real time and predict trends before they happen. Section 6. Cryptography, the art of keeping secrets. Ever wonder how your passwords stay safe online? That's thanks to cryptography. Cryptography is the art of keeping information secure, and it's all built on math, particularly number theory. At the heart of modern cryptography is something called RSA encryption. This technique relies on the fact that breaking a large number into its prime factors is incredibly hard. Example: consider a public key that encrypts your message. Only the person with the private key can decrypt it. This ensures that even if someone intercepts the message, they can't read it without the private key. For instance, if your message is turned into a long string of numbers, only the intended recipient can turn it back into readable text. And when I say hard, I mean it would take more computing power than exists in the world to crack some of today's encryption codes. But cryptography isn't new. Even in ancient times, people used ciphers to hide their secrets. One famous example is Julius Caesar, who used a simple cipher to encode his messages. Example: during wartime, he would shift the letters of the alphabet to confuse his enemies. This kind of simple substitution cipher was one of the earliest forms of encryption. If he wanted to send the message ATTCKATDN, he might encode it to DWDF and DWGZQ by shifting each letter 3 places forward. And now, Cryptography protects everything from your bank account to your phone's unlock code. It's why hackers can't just guess your credit card number or break into secure systems.